My name is Aiden, and today I will be walking you through the gal operon and all of its components and how it works, and a mutation that is involved with it. Here we have all of the pieces that make up the gal operon. This is the line that is transcripted on. This is the RNA polymerase. Here's the gal4p, the MIG1, which is usually outside of the nucleus, the TUP1, glucose if it is introduced, galactose if it is introduced, the gal-ADP, the ATP that is part of the process, and everything this way is upstream. This is the gal gene system in yeast. These genes, gal1, gal7, gal10, are scattered over many chromosomes and encode enzymes required to metabolize galactose. Upstream of the genes is the UASG, where the activator gal4 binds. RNA polymerase binds at the promoter to transcribe the genes. Gal4 is always bound to UASG and can activate transcription. However, in the absence of galactose, gal-80 will bind to gal4, and this blocks its activation domain. So RNA cannot go across. Because gal4 is inhibited, RNA polymerase is not effectively recruited, and transcription of the gal genes is off. When galactose is present, it binds to gal3. So galactose is in the system, it ends up binding to gal3 along with ATP. Gal3 then interacts with gal-80 and removes it from gal4. With gal-80 no longer blocking it, gal4 becomes active, and gal4 recruits RNA polymerase and transcription of the gal1, 7, and 10. So transcription is on. When glucose is present in the system, the protein MIG1 is dephosphorylated and enters the nucleus. So usually it's in the cytoplasm, but now since it's dephosphorylated, it can come all the way in and enter the nucleus. MIG1 binds near the promoter region with his buddy TUP1. So MIG1 and TUP1 are together now. TUP1 is a core repressor. TUP1 alters chromatin structure and represses the transcription. So it blocks RNA polymerase. As a result, after it goes on gal4, as a result, the gal genes are off or expressed at very low levels, even if galactose is present. But for this system, glucose is present, and when these two repressors go on, RNA polymerase cannot go through. However, if MIG1 is mutated, it cannot bind to the DNA, and it cannot recruit TUP1. So glucose repression fails, and even though glucose is in the system, the gal genes are still expressed despite glucose being present, which is not what you want to happen because it is not energy efficient. This is what happens when MIG1 is mutated. In summary, gal4 activates transcription at the UASG, which is next to the promoter. Gal-80 inhibits gal4 in the absence of galactose. Gal-3 removes gal-80 when galactose is present to allow that transcription. MIG1 and TUP1 repress transcription in the presence of glucose, and the maximum expression occurs when galactose is in fact present and glucose is absent.